Less than 5% of the population understands what is actually happening to the climate right now. That is not a guess. That is what the polling has been saying for years. 26% of adults are alarmed about climate change, but only about 3 to 5% can name the specific mechanisms, identify the tipping elements, or tell you why this particular calendar year matters more than the last one. The other 95% are scrolling past the most important story of their lifetimes without realizing it. And on the first day of June this year, a forecast dropped that converts everything climate scientists have been warning about for 4 decades from a probability into a number. A single chart. 51 model runs converging on +3 degrees by December. The strongest El Niño the planet has measured in 150 years, forming on top of the warmest baseline civilization has ever existed inside. If you want to understand what no one is talking about while it is happening, what crosses the Paris threshold, what loads the cascade, what closes the Holocene window, you're in the right place. Hit the subscribe button if you want the seasonal scale climate story most coverage refuses to connect, and drop a comment telling me where you're watching from and whether you had already heard about the June 1st forecast before this video. Share this with someone who deserves to be part of the 5%. Now, let's get into it. Part 1. The plume. That converged on the first day of June, 2026, the European Centre for Medium-Range Weather Forecasts released the latest update of its seasonal forecasting system, the system they call SEAS5. By the end of that same afternoon, one image from that release was spreading across social media faster than any seasonal forecast image in recent memory. It was a plot. It looked, at first glance, like a tangle of red lines climbing up and to the right, across a graph that ended in December. It was technically a Niño 3.4 anomaly ensemble plume, 51 separate model runs, each tracing one possible future for sea surface temperatures in a particular patch of the equatorial Pacific, all stacked together on one chart. To most people scrolling past it, it looked like noise. To people who read these plumes for a living, it looked like the moment a forecast stops being a forecast and starts being a verdict. The 51 red lines on that chart were converging. They were not spreading out the way ensemble members usually spread out when you ask a model to predict 6 months into the future. They were bundling. By December 2026, the bundle was tight, and the bundle was sitting at 3 degrees Celsius above the long-term climate baseline for that piece of ocean. The highest member in the ensemble was at about 3.5 degrees. The lowest member of the entire 51-member ensemble was still above +2.5. And in the middle, the ensemble median was sitting at +3 degrees flat, like the model had stopped guessing and started reporting. That kind of convergence is not how seasonal forecasts normally behave. There is a thing in atmospheric science called the spring predictability barrier, a well-documented period from about April through June every year during which seasonal forecast skill collapses. The reason it collapses is technical, but the intuition is simple. The upper layer of the tropical Pacific Ocean is too thin during those months to carry strong predictive signal forward. The signal you need to predict an El Niño or a La Niña dissolves into the noise. Every forecast model in the world produces wider ensemble spreads in that window. You expect the lines to fan out. You expect the uncertainty to grow. That is what the physics of the system imposes on the forecast. The June 1st SEAS5 plume did the opposite. The lines did not fan out. They tightened. The spread narrowed past what the model would normally produce for that lead time, with that initialization date, beyond that barrier. And when a coupled ocean atmosphere ensemble forecasting system produces a narrow spread past the predictability barrier, what it is telling you, in the language of probability and uncertainty, is that the residual uncertainty in the trajectory has been resolved. The forecast is no longer a question of which scenario the system might evolve into. The forecast is the system reporting that the trajectory has been determined. The dynamics underneath are now strong enough that the model cannot find a way to talk itself out of where this is going. That is what convergence past the spring predictability barrier means. That is why people who read these charts were stopping their work on the first day of June to send the image to each other with no comment. There was nothing to say about it that the chart did not already say. The 51 members had collapsed onto an answer. The answer was +3 degrees by December. Let me back up and explain what the Niño 3.4 region actually is, because the strength of this story depends on understanding that we're talking about one very specific piece of ocean and not the whole Pacific. The Niño 3.4 region is a rectangle drawn on the equatorial Pacific Ocean. The rectangle stretches between 5 degrees north latitude and 5 degrees south latitude, so it straddles the equator by 5 degrees on each side. East to west, it stretches from 170 degrees west longitude to 120 degrees west longitude, so it sits in the central Pacific, well west of the South American coast, well east of the dateline. That rectangle is the standard reference patch climate scientists use to track the El Niño Southern Oscillation. When you read in a news headline that an El Niño is forming, the headline is talking about sea surface temperatures inside that rectangle drifting above their long-term average. When the average inside that rectangle stays above plus 0.5 degrees Celsius for a few months in a row, that is officially called an El Niño. When it stays below minus 0.5, that is La Niña. The reason the world cares about the temperature inside that one specific patch of ocean is that the atmosphere over the equatorial Pacific drives weather patterns across the entire planet through a chain of teleconnections that climate scientists have been mapping out since the early 20th century. The chart that converged on the 1st of June was forecasting the average temperature inside that rectangle, month by month, all the way through the end of the calendar year, and it was saying, with the highest available confidence the forecasting system has produced for this region, that by December 2026, the temperature inside that patch of ocean will be 3 degrees Celsius above the long-term mean. To put that number in context, you have to know what the thresholds are. The official Climate Prediction Center scale calls an event a weak El Niño when the Niño 3.4 anomaly reaches about plus 1 degree. A moderate event is around plus 1.5. A strong event is around plus 2 degrees. A super El Niño is anything at or above plus 2 degrees that also sustains. The June 1st SIAS 5 plume is not just forecasting an event in the strong category. It is forecasting an event that overshoots the super El Niño threshold by a full degree in its ensemble median, with an upper bound approaching plus 3.5. Even the coldest member in the entire 51-member ensemble is above plus 2.5. Every single scenario the model can generate from the current state of the system lands in super El Niño territory or higher. This is a forecast for an event that, if it verifies, would sit at or above the upper boundary of the modern instrumental record. We have not measured sea surface temperatures in the Central Pacific with reliable instrumentation for very long. Really only since the 1982 through 83 event was carefully tracked by a still young observational network, and certainly with full confidence only since the deployment of the Tropical Pacific Ocean Buoy Array in the early 1990s. Inside that observational window, the peak Niño 3.4 values for the 3 most extreme El Niños on record are well documented. The 1982 through 83 event peaked at about plus 2.1 degrees. The 1997 through 98 event peaked at about plus 2.4. The 2015 through 2016 event peaked at about plus 2.6. The June 1st SIAS 5 forecast is calling for a December value of plus 3. If the forecast verifies, this is bigger than 1997 through 98. It is bigger than 2015 through 2016. It is bigger than any El Niño that has been instrumentally measured. To find a comparable event, you have to reach back beyond the modern instrumental record entirely. And the place you have to reach back to is the reason the phrase strongest in 150 years started circulating online the same week. We will get to that in a few minutes, but before we get there, we need to understand why this particular forecast, this particular June 1st plume, is generating the reaction it is generating among the people who do this for a living. Because forecasts have been calling for a strong El Niño in late 2026 for months now. The May 1st SIAS 5 initialization had already drawn attention. The CFS version 2 model had already extended its y-axis ceiling to plus 4 degrees. The North American multi-model ensemble had been showing the same range. The signals have been there. What changed on the 1st of June was the convergence. There is a difference between a forecast that says here is a wide range of possible outcomes, the high end of which is dangerous, and a forecast that says the range has collapsed. The high end is the only option left, and the only remaining question is exactly how high. The May 1st plume was the first kind of forecast. The June 1st plume is the second. That is why the people who read these charts stopped what they were doing. The model committed. And when a multi-billion-dollar coupled ocean-atmosphere ensemble forecasting system, run by the most respected operational weather forecasting institution in the world, commits to a number this far past the threshold, this far past the predictability barrier, The question that opens, the question every climate scientist who looked at that chart on the 1st of June started asking, is the question we are going to spend the rest of this video trying to answer. The question is not whether the El Niño is forming. The model has answered that. The question is what +3 degrees in that specific piece of ocean does to the rest of the planet, and what it tells us about a much larger story that has been building since long before this forecast existed. Because this plume is not the beginning of the story. This plume is the moment the story can no longer be argued with. Part 2. How 6 months of numbers took us here. Before we go further, I want to walk you through how we know the forecast is not just a model talking to itself. Because the immediate reaction from people who do not work in climate science, when they see a chart like this, is reasonable skepticism. Models are models. They are run on assumptions. The output reflects the input. If the input is wrong, the output is wrong. The natural follow-up question is, what is the chart actually grounded in? What is the observational evidence that the El Niño is forming separate from what the European Centre's forecast model thinks? The answer is the Oceanic Niño Index, the ONI. This is the official metric NOAA's Climate Prediction Center uses to declare ENSO conditions. It is constructed from real measurements, sea surface temperature readings from satellites, ship reports, drifting buoys, the tropical Pacific moored buoy network. The ONI takes those real measurements inside the Niño 3.4 region, calculates the monthly anomaly from the long-term mean, and then computes a 3-month running average. The running average smooths out short-term noise and gives you a clean read on whether the underlying ocean state is actually warming, actually cooling, or actually neutral. The ONI is a backward-looking number. It is not a forecast. It is an observation. It is what the ocean has been doing, averaged over the last 3 months. And the trajectory of the ONI over the past 6 3-month windows is what gives the June 1st forecast its observational grounding. 6 months ago, in the October through December 2025 season, the ONI was at -0.55. That was officially a weak La Niña. The Pacific was cooler than average. The next overlapping 3-month window, November through January, came in at -0.54. Essentially flat, still La Niña, still cool. Then the values started to warm. December through February dropped, meaning the cool anomaly weakened, to -0.37. January through March came in at -0.14, almost touching neutral. February through April crossed into positive territory for the first time, at +0.13. And the most recent reading, the March through May 2026 average, just came in at +0.48. The trajectory label that NOAA has attached to the data is the single word warming. Walk through what just happened there. In 6 consecutive 3-month windows, the ONI moved from -0.55 to +0.48. That is a swing of 1.03 degrees Celsius in the average ocean temperature of the Niño 3.4 region across 6 seasons, 1 full degree plus a little extra in 6 3-month windows. That is not normal. That is not the rate at which ENSO normally transitions between states. Normally, when the Pacific is moving from La Niña to El Niño, the swing happens at a slower pace, and there is usually a neutral plateau in between where the system pauses before committing to the other phase. The current transition has not paused. It has not plateaued. It has accelerated straight through neutral into warm. The last time we saw an ONI swing at this speed was during the 2014 into 2015 onset. That earlier transition produced the 2015 through 2016 Super El Niño. And that earlier transition, fast as it was, still required slightly more than 6 seasons to traverse the same range we have just traversed. The current swing is at the upper edge of the historical envelope. Some climate scientists are arguing it is past the upper edge. The point either way is the same. The observed trajectory of the real measured ocean is moving faster than the historical baseline says it should be moving. The forecast model on the 1st of June converged on +3 degrees by December, because the observed trajectory underneath the forecast is moving at a rate that puts +3 degrees by December squarely on the deterministic part of the curve. NOAA's Climate Prediction Center responded to that trajectory by issuing an El Niño Watch. A watch in NOAA language is the formal institutional acknowledgement that the conditions are favorable for the development of an El Niño event in the near future. The probability numbers attached to that watch tell you how confident the CPC is. the probability of El Niño onset during the May through July 2026 window, and remember, we are inside that window right now, is between 82 and 98%. So between 82 and 98 chances out of 100 that the official threshold for declaring an El Niño event is crossed within the next 2 months, if it has not been crossed already. The probability that the event persists into the 2026 into 2027 winter is 96%. Almost certain. The probability of the event reaching strong or very strong intensity at peak is approximately 1 in 3 under conservative assumptions, and substantially higher than 1 in 3 under the ECMWF and CFS version 2 trajectories. That is one centre's forecast, the Climate Prediction Centre alone. But the story gets stronger when you look at what every other forecasting centre is independently saying. The International Research Institute for Climate and Society, known as IRI, produces a multi-model ENSO probability assessment that is updated monthly. The May 2026 IRI plume gives a 94% probability of El Niño being in place during the October through December window. It gives a 25% probability that the event crosses the super El Niño threshold of +2 degrees. That last number is the conservative read on the question. 25% is 1 in 4. The ECMWF and CFS version 2 trajectories say more than that, but even the IRI plume, which aggregates across multiple modelling systems and includes the conservative ones, is putting 1 in 4 odds on the super El Niño threshold being crossed. The NOAA Climate Forecast System version 2, that is CFS version 2, the United States Operational Seasonal Forecasting Model, produced its own May 1st plume update. The notable feature of that update was that the y-axis ceiling on the standard plume display had to be extended. The usual y-axis cap for CFS version 2, Niño 3.4 forecast has historically been around +3 degrees, because almost no ensemble members ever wandered higher than that. The May 1st update had members exceeding +3. To accommodate them on the chart, the y-axis was extended to +4 degrees. That is a small technical detail that says a lot. The model is producing scenarios that the chart display software was not originally built to show. The North American Multi-Model Ensemble, NMME, runs multiple American and Canadian forecast models in parallel and averages their output. The May 2026 NMME update for the October through December window shows Niño 3.4 anomalies in the +2 to +3 degree range across the model ensemble. So the United Kingdom Met Office GLOW-C system, the Japan Meteorological Agency seasonal forecast, the IRI multi-model assemblage, the United States CFS version 2, the United States NMME, and the European Centre's SEAS-5 system, 6 independent major operational seasonal forecasting systems, are all producing trajectories in the +2 to +3 degree range for late 2026. They do not share code, they do not share assumptions. They are built on different physical parameterizations, different ocean model architectures, different atmospheric coupling schemes. They agree because the observational signal underneath them, the subsurface ocean state, the surface trade wind pattern, the equatorial warm pool position, is now strong enough that every independent modelling system, looking at the same input data through different lenses, arrives at the same forecast. When 6 independent modelling centres produce the same answer from different starting points, that is the closest thing seasonal forecasting can produce to certainty. The model convergence is not a quirk of one centre's calibration. The model convergence is consensus on what the physical system is telling all of them. The argument that the SEAS-5 plume is just one model running its biases would have to explain why every other major modelling system in the world is producing the same biased answer at the same time. The argument fails on its face. The chart is grounded in observation. The observation is grounded in the trajectory of an ocean that is no longer behaving the way a La Niña Pacific is supposed to behave. We covered the very early stage of this transition in our video from the 27th of May, the one on the extreme drought that was breaking. The drought reversal video walked through the same ONI swing data, but at that point it was the swing from -0.55 to +0.13. 6 months of warming had been happening, and the front edge of that warming was just then arriving in the form of tropical moisture, pushing back into a continent that had been in drought. The May 27th number, +0.13, was the moment the Pacific officially stopped being La Niña and started being neutral on the warm side. The June 5th update, plus 0.48, which is what we have today, is the moment the Pacific is on the cusp of crossing into the official El Niño threshold itself. Plus 0.5 is the official line. We are at plus 0.48. By the next ONI update, we will almost certainly be over the line. What that means, in plain terms, is this. The forecast for plus 3 degrees by December is grounded in an observed trajectory that has been pushing the Pacific from cool La Niña into warm El Niño at the fastest rate measured in over a decade. The forecast is not the model telling you what it imagines. The forecast is 6 independent modelling systems projecting forward the path that an already moving ocean is on. Every weekly buoy update, every monthly ONI calculation, every satellite SST anomaly map has been confirming that the path is on track. The numbers are not noisy, the numbers are consistent, and they are moving in one direction. And that direction is being driven by something happening underneath the surface that the surface readings alone do not capture. The reason the forecast can commit to plus 3 degrees by December is that the ocean has already loaded the next several months of warming below the waterline. The Kelvin wave that we are about to talk about is the part of this story that most people do not see, because most people do not look at subsurface buoy data. But the subsurface is the proof that the surface signal is not noise. The subsurface is the engine that is going to push that surface anomaly to plus 3 by the end of the year, and it is already in motion. Part 3. The wave. Already moving. Most of the public conversation about El Niño focuses on sea surface temperatures, because the surface is what the satellites can see most easily, and the surface is what generates the headline-worthy maps. But the El Niño phenomenon is not really a surface event. The surface is just where the signal becomes visible. The actual physics of El Niño formation is buried in the upper few hundred meters of the equatorial Pacific Ocean, in a layer that sits beneath the surface mixed layer and above the deep thermocline. That layer is where the heat content of the tropical Pacific is stored, and that layer is where the build-up that precedes every major El Niño event takes place. If you want to know whether an El Niño is real, whether it is going to land and how strong it is going to be, you do not look at the surface, you look at the subsurface. The instrument that tells us what the subsurface is doing is called the Tau Triton Buoy Array. It is a network of moored buoys spread across the equatorial Pacific that was deployed in stages during the 1980s and 90s and has been maintained continuously by NOAA and by Japan's research agencies ever since. Each buoy is anchored to the ocean floor. Each buoy has sensors at multiple depths, typically at the surface, and at 100 meters, 200 meters, 300 meters, 500 meters, and 700 meters. The sensors measure temperature. They transmit the readings back to NOAA via satellite. The dataset is freely available, updated daily, and is the gold standard for monitoring the equatorial Pacific subsurface in real time. When climate scientists want to know what the equatorial heat content is doing, they look at Tau Triton. The Tau Triton array right now is showing something specific. There is a downwelling Kelvin wave propagating eastward across the equatorial Pacific. Let me unpack what that means, because the phrase Kelvin wave gets used a lot in El Niño coverage and is rarely explained clearly. A Kelvin wave, in the ocean, is a kind of large-scale wave motion that travels along the equator with the planet rotating to one side. Because of the Coriolis effect, an oceanic Kelvin wave can only propagate eastward in the Pacific. It travels at a speed of about 2.5 meters per second, slow enough that it takes a Kelvin wave roughly 2.5 months to cross the entire equatorial Pacific from the western boundary near Indonesia to the eastern boundary at South America. The wave is not a surface wave that you would see if you were on a boat. It is a deep wave, with most of its motion happening tens to hundreds of meters below the surface. As it moves eastward, it carries warm water with it, depressing the thermocline, the boundary between warm surface water and cold deep water, and pushing the warm layer eastward and shallower as it goes. A downwelling Kelvin wave is the specific kind of Kelvin wave that warms the equatorial Pacific. It pushes the thermocline down on its leading edge. It thickens the warm surface layer. It transports heat from the western Pacific warm pool, the patch of ocean near Indonesia and the Philippines that is the warmest large body of water on Earth, eastward toward the central Pacific and ultimately toward the South American coast. When the warm water arrives at the eastern boundary, it suppresses the normal upwelling of cold water that keeps the eastern equatorial Pacific cool. The cold tongue weakens, the surface warms, the trade winds, which normally blow east to west and which are partly driven by the temperature contrast between the cold eastern Pacific and the warm western Pacific, weaken in response. The weakened trades fail to maintain the normal east to west piling of warm surface water in the western basin. More warm water leaks east. The cycle reinforces itself. That self-reinforcing cycle is called the Bjerknes feedback, after the Norwegian-American meteorologist Jacob Bjerknes, who described it in a 1969 paper in the journal Monthly Weather Review titled Atmospheric Teleconnections from the Equatorial Pacific. Bjerknes did not have satellite data. He did not have buoy networks. He looked at ship reports, surface pressure measurements, and Tahiti versus Darwin sea level pressure differences, and he wrote down the feedback loop that decades later became the textbook explanation for what an El Niño actually is. Weakened trades reduce upwelling. Reduced upwelling warms the eastern Pacific. Warm eastern Pacific weakens trades further. Once the cycle gets going past a certain threshold, it cannot easily reverse. The forecast model committing to plus 3 degrees by December is a forecast model that has identified the Bjerknes feedback as having engaged and as being well past the point where it could plausibly reverse before the calendar year ends. The downwelling Kelvin wave that is currently propagating across the equatorial Pacific got started by something specific. In December 2025, a westerly wind burst occurred over the western equatorial Pacific. A westerly wind burst is exactly what it sounds like. A brief, intense period of winds blowing from the west to the east against the normal trade wind direction. Westerly wind bursts are themselves driven by the Madden-Julian oscillation, which is a slow-moving atmospheric pulse that travels eastward around the tropics on a roughly 30 to 60-day cycle. The December 2025 westerly wind burst pushed warm surface water eastward, depressed the thermocline at the eastern edge of the burst, and launched a downwelling Kelvin wave. Then, in January 2026, a second westerly wind burst occurred. The MJO was in its phase 3 through 5 envelope, the envelope in which atmospheric convection over the equatorial Pacific is enhanced, and the second burst arrived on top of the first. It reinforced the Kelvin wave. It added energy to the propagating signal. By February, the wave was moving eastward across the basin, with momentum that the next several months of observations would only continue to extend. What that wave has been carrying is the heat content that is going to surface in the next few months as a Niño 3.4 anomaly. The Tau Triton Array is reading, right now, subsurface temperature anomalies of plus 5 to plus 6 degrees Celsius above the long-term mean at the 100-meter depth horizon. That is across most of the equatorial basin. At certain individual buoy nodes, particularly in the central and eastern Pacific where the wave is currently piling up, the readings are higher. Some nodes are showing plus 6 to plus 7 degrees Celsius at 100 meters. To put that in human terms, that is the equivalent of a swimming pool warmed by 10 or 12 degrees Fahrenheit, but covering an area larger than the continental United States, at a depth that the surface cannot see directly, but that the surface will inherit as the wave continues to push the warm layer upward. This subsurface signature is comparable to the strongest analogues in the modern record. The 1997 through 98 onset, which is generally regarded as the strongest El Niño in the instrumental era, had a subsurface preparation that registered in a similar range of plus 4 to plus 6 degrees at the 100 to 150 meter horizon. The 2015 through 16 onset had a comparable signature. We covered the surface manifestation of the current heatwave in the Pacific in our video from a couple of weeks ago, the one on the heatwave currently forming in the Pacific. That video walked through the buoy-tracked warm pool that was already showing plus 5 to plus 6 degrees at 100 meters. What we are looking at today is the same signature, 2 weeks further along, with the wave continuing to propagate eastward and the leading edge now positioning itself for the surface emergence that the next several months will reveal. The video from a couple of weeks ago showed the engine. Today we are watching the engine drive the surface. The trade winds are doing what the Bjerknes feedback predicts they should do. They are weakening. The cross-Pacific pressure difference, the gradient between high pressure in the eastern Pacific and low pressure in the western Pacific that drives the normal easterly trade flow, is weakening. The Southern Oscillation Index, which is the standard measure of that pressure gradient, has been trending negative for months. Negative Southern Oscillation Index values are the atmospheric signature of El Niño. The atmospheric side and the oceanic side are now coupled and pulling in the same direction. The reason this all matters for the forecast is that the subsurface signal is leading. The surface signal is following. The warm water under the buoys is not future warming. It is past warming that is now en route to the surface. Once a Kelvin wave of this magnitude is moving, the surface manifestation over the following 3 to 6 months is mostly a question of timing, not a question of weather. The forecast is committing to +3 degrees by December because the heat that will become the +3 degree anomaly is already in the upper 150 meters of the equatorial Pacific. The model is not imagining heat that does not exist yet. The model is integrating heat that already exists forward to the time when it will arrive at the surface. That is the proof. The surface signal could in principle be noisy. The model could in principle be wrong about how the atmosphere will respond. But the subsurface heat content is measurable. The buoys are reading it. The satellites are confirming it. The Argo profiling floats. The global network of autonomous ocean profilers that drift through the upper 2 kilometers of the ocean and report temperature and salinity at every level are confirming it. The independent observational systems are all telling the same story. The Kelvin wave is real. The heat load is real. The forecast for +3 degrees by December is grounded in measurements of heat that is already in the system. And once you accept that the El Niño is forming, and that it is forming with a subsurface signature comparable to or exceeding the strongest analogues in the modern record, the next question is the one we have been deferring this whole video. What does +3 degrees in that piece of ocean actually do to the rest of the planet? And what does it mean that we are forecasting an event of this magnitude in this particular calendar year, on top of the climate state we have already built? Because the El Niño is not arriving into a world that resembles the worlds in which previous super El Niños have arrived. It is arriving into a world that is already loaded with conditions that strong El Niños have not previously had to amplify. The setup is different. The baseline is different. And the historical reference point that has been getting tossed around online since the forecast dropped, the phrase strongest in 150 years, is a reference point that points at something very specific and very dark in the historical record. We need to talk about that next because it is the literal meaning of what the forecast is forecasting. Part 4. What's strongest in 150 years? Actually means when the seas, 5 plume, converged on the 1st of June, a phrase started appearing alongside it in the same social media conversations. The phrase was strongest El Niño in 150 years. It was on the climate scientists' posts. It was on the news pieces. It was on the explainers. It became the headline framing within hours, and it is a phrase that almost everyone read past without slowing down to ask the obvious question. What was happening 150 years ago? Why 150? Why not 100? Why not 200? Why is that specific number the reference point? The answer is that 150 years before 2026 lands you at 1876. And 1876 is the year a specific climate event began that nothing in the subsequent observational record has matched. The El Niño that started in 1876, and the parallel events around the world that it triggered, are the reference point for the phrase strongest in 150 years. The phrase is not a round number chosen for marketing. The phrase is a literal citation. The historical event it cites was the worst climate-amplified humanitarian catastrophe in the modern era. We need to talk about it, because the magnitude the forecast is calling for in December 2026 is the magnitude the 1876 event reached at its peak. The reason the climate science community is reacting to the June 1st plume the way it is reacting is that they all know what 150 years ago means. Most of the rest of us do not. We covered this in detail in our video from April 23rd, the one on the last El Niño that looked like this. That earlier video walked through the 1876 event in full. If you have not seen it, the short version is that an El Niño formed in 1876 that was, in equivalent-only terms, reconstructed from coral cores and tree rings and contemporary meteorological records, between +2.5 and +3 degrees at its peak. It coincided with the strongest positive Indian Ocean dipole event in the historical reconstructions. That is the Indian Ocean equivalent of an El Niño-like east-west temperature swing, and it coincided with extreme sea surface temperatures in the North Atlantic. 3 independent ocean basins, all at extreme states, all at the same time. The combination produced a multi-region failure of the monsoon systems across the entire belt of the tropics. The Asian summer monsoon failed across India and parts of China. The South American monsoon failed across Brazil and the Northeast. The East African monsoon failed across the Horn of Africa. Crops failed simultaneously across 4 continents. The result was what historians now call the Great Famine of 1876 through 78. The estimated death toll across India, China, Brazil, and East Africa is somewhere between 30 million and 50 million people. The exact number is contested by historians. The lower bound of 30 million is conservative and is supported by the cleanest demographic reconstructions. The upper bound of 50 million is supported by some of the more aggressive estimates that include excess mortality from disease and displacement in the years immediately following. Either way, the death toll is at a scale that has no peer in the climate record. The 1876 event is not in the same category as the Dust Bowl or the European heatwave of 2003, or any of the more familiar climate-amplified disasters of the 20th century. The 1876 event is in its own category. The reason it killed at that scale is that the climate trigger arrived in a world that amplified it through specific structural failures. Mike Davis's 2001 book, Late Victorian Holocausts, which is the standard popular treatment of the 1876 famine, makes the argument that the death toll was a product of the climate trigger plus the colonial economic policies that governed the affected regions. The British administration in India continued exporting grain from famine-affected districts to Britain throughout the worst of the crisis. The Indian colonial administration used the famine as an occasion to enforce free market doctrine on food distribution, refusing to interfere with the price mechanism even as prices put food beyond the reach of the affected population. The colonial economic structures turned a climate trigger into a mass death event by removing the buffers that might have absorbed it. Davis's book is not the only source on this, but it is the one most likely to come up if you go looking for the 1876 famine in a bookstore today, and it lays out the argument with full historical citation. The 1876 death toll is not a story about how climate alone kills, it is a story about how climate combined with political and economic structure kills. The peer-reviewed academic citation for the climate side of the same event is a paper by Singh and Seeger, and Cook, and Kane and Ting and Cook, and Davis, published in 2018 in the Journal of Climate. The paper is titled Climate and the Global Famine of 1876 through 78. The DOI is 10.1175/J CL-I-D-18-0159.1. The team is from NASA Goddard Institute for Space Studies and from Columbia University's Lamont Doherty Earth Observatory. The paper attributes the famine specifically to the simultaneous occurrence of the strongest recorded El Niño, plus the strongest positive Indian Ocean dipole, plus the elevated North Atlantic sea surface temperatures. Their reconstructed peak Niño 3.4 equivalent is in the plus 2.5 to plus 3 degree range. That is the source for the number that the current forecast is comparing itself to. Now here is what makes the comparison meaningful and what makes it limited at the same time. The current forecast is calling for a peak Niño 3.4 anomaly of plus 3 by December 2026. The 1876 event reconstructed peak is in the plus 2.5 to plus 3 range. The magnitudes are comparable. The current forecast is at or potentially above the 1876 analogue. That is the meaning of the phrase strongest in 150 years. There is no event between 1876 and today that matched that magnitude. The events we have measured, 82 through 83 at plus 2.1, 97 through 98 at plus 2.4, 2015 through 2016 at plus 2.6, all came in under the 1876 peak. The current forecast is the first one we have ever produced that puts the modern equivalent on the table, but the question of what the current event will produce in terms of human consequences is a much harder question than the question of what the climate signal will be. The world of 2026 is not the world of 1876. We have irrigation systems that did not exist in colonial India. We have grain reserves that the British administration did not maintain. We have satellite weather observation that gives multiple weeks of lead time on monsoon failures. We have international trade in cereals that allows the system to shift commodities from surplus regions to deficit regions. We have seasonal forecasting itself, the very tool that produced the SEAS-5 plume, which gives policymakers the chance to act before the event lands, instead of after. The buffers we have built into the global food system over the past century are real, and they are substantial. We should not pretend that they are not. We also should not pretend that they are perfect. The The world of 2026 is also a world with 8.5 billion people, concentrated heavily in tropical and subtropical regions that are the leading edge of warming impact. The world of 2026 has agricultural systems that have been calibrated against the climate baseline of the late 20th century, not against the baseline that an event at this magnitude on top of an already elevated background would produce. The world of 2026 is more economically interconnected than the world of 1876 was, which means that supply chain disruptions in one region propagate more quickly to other regions. The world of 2026 has political systems that are demonstrably struggling to coordinate any response to slow-onset climate impacts. The buffers are different. The vulnerabilities are different. The argument that we will not see 1876 again because the world has changed is the optimistic read. The argument that we will not see 1876 because the world has changed in ways that introduce new vulnerabilities that the buffers do not address is the realistic read. The honest answer is that we do not know yet, because no one has tested the modern global food system against a climate trigger of this magnitude on top of an elevated baseline. The 2026 through 2027 event is going to be the test. The Sky paper from 2014 in Nature Climate Change makes one more relevant point that we need to put on the table. Sky and his co-authors looked at the historical frequency of extreme El Niño events of the magnitude that produces the global teleconnection cascade that triggered the 1876 famine, and they looked at how that frequency changes under greenhouse warming. The answer they came to is that the frequency of extreme El Niños doubles under sustained greenhouse warming. The reason is mechanistic, not statistical. The warming pattern shifts the position of the warm pool, alters the trade wind structure, and makes the equatorial Pacific more conducive to the kind of feedbacks that produce extreme events. The Sky paper has been confirmed and extended in subsequent literature. The upshot is that we should not think of the current event as a one-off. We should think of it as the leading edge of a new statistical regime in which extreme El Niños arrive twice as often as the historical baseline. The 1876 analogue is not just the reference point for this event. It is the reference point for the kind of event we should expect to keep arriving at decreasing intervals. That brings us back to the central argument. The forecast is for an event at the magnitude of the worst climate-amplified humanitarian catastrophe in modern history. The climate signal is comparable. The world is different in ways that include both real buffers and real new vulnerabilities. The question of what happens when this event lands is not yet answered. And the larger question, the question of whether the climate band we built civilization inside is the climate band that civilization can still operate inside, is the question that the 1876 analogue forces us to ask. Because civilization in 1876 did not survive that event intact in the affected regions. Tens of millions of people died. The political and economic systems that governed those regions had to be substantially reorganized over the following decades, partly in response to the famine. The 1876 event was a stress test on the global civilization of its time, and the global civilization of its time failed that stress test catastrophically. The June 1st plume is forecasting an event at the same magnitude. The world has changed. The question is whether it has changed in the right direction. And underneath that question is a larger one, which is whether the climate baseline against which we built every modern system has been changing fast enough that the systems are now operating outside the conditions they were designed for. We need to talk about that next. Part 5. The background that makes this worse. Even if the El Niño we are forecasting were arriving into a planet that resembled the planet of 1876, it would be the strongest event in 150 years, and that would be the story. But the El Niño is not arriving into the planet of 1876. The El Niño is arriving into a planet whose baseline ocean temperature is approximately 1.2 degrees Celsius warmer than the 1876 baseline. That extra 1.2 degrees is not part of the El Niño signal. It is the background condition the El Niño signal is being added to. And when you add a +3 degree El Niño anomaly on top of a baseline that is already 1.2 degrees warmer than the historical reference, you do not get the same outcome you would get from adding the same anomaly to the historical baseline. The consequences compound non-linearly. The atmosphere does not respond to the El Niño as if the baseline were the same. The atmosphere responds to the absolute temperatures the system is producing, and the absolute temperatures the system is going to produce in late 2026 and into 2027 are going to be the highest absolute temperatures the equatorial Pacific has been at in instrumentally measured history. This is where the Hansen baseline framing matters. James Hansen, who you may know as the climate scientist who in 1988 testified before the United States Congress that human-caused warming had become measurably detectable in the climate record, and who has spent the 4 decades since then arguing that the climate science community has been systematically conservative in its communication relative to what the data shows, has been making a specific argument about the current period. The argument is that the recent acceleration in global temperatures is the product of multiple compounding factors, and that the El Niño contribution is going to interact with those other factors in ways that produce a higher annual mean global temperature in 2026 than the existing records have prepared us for. The Hansen Group's 2023 paper in Oxford Open Climate Change laid out the framework. The Hansen Substack posts in 2026 have been refining and pushing it forward. The headline claim from Hansen, stated with high confidence on his own Substack in 2026, is that 2026 will definitively surpass 2024 as the warmest year on record. The El Niño that is now forming is the proximate driver of that prediction. The aerosol unmasking that we'll talk about in a few minutes is a secondary contributor. The combination produces a global mean temperature trajectory that crosses thresholds the conservative institutional projections were not putting on the table for this calendar year. The math, in its simplest form, is straightforward. You take the global mean temperature for the most recent comparable La Niña to El Niño transition cycle, which is approximately plus 1.3 degrees Celsius above the 1850 through 1900 pre-industrial baseline. You add the contribution from the rising background of greenhouse gas warming over the past several years, which has been running at roughly plus 0.02 degrees per year. You add the contribution from the IMO 2020 aerosol unmasking, which is in dispute but ranges from approximately plus 0.01 to plus 0.05 degrees by the Hansen estimate. And you add the contribution from a super El Niño at the upper end of the historical range, which has historically added between plus 0.1 and plus 0.25 degrees to the annual mean during the year of the event peak. You sum those contributions and you arrive at a global mean for 2026 somewhere between plus 1.5 and plus 1.7 degrees above the pre-industrial baseline. That central estimate is at or above the Paris Agreement aspirational limit of plus 1.5 degrees Celsius. The Paris limit is, technically, a sustained multi-decade average, not a single-year value. Crossing it for 1 year does not trigger the formal definition of having exceeded the limit. The institutional language for that is that the limit is exceeded when the multi-decade running average crosses it, which is a higher bar than any single annual mean. The reason that distinction matters is that the climate science community has been careful, in its public communication, not to overstate the implication of any single year crossing. A single hot year does not by itself mean the world has left the Paris-compatible trajectory. The multi-decade trend is what matters for the formal framework, but the leading indicator, in any forecast of when the sustained crossing will happen, is the single-year crossing. The first time the annual mean crosses plus 1.5 degrees is the first signal that the sustained crossing is approaching. The 2024 annual mean came in at approximately plus 1.3. Hansen's prediction is that 2026 will surpass 2024. The C's 5 plume is the forecast that grounds that prediction in the El Niño contribution. The combination predicts that 2026 will be the first calendar year in which the annual mean global temperature crosses plus 1.5 degrees as a single-year value. That is the threshold crossing event. That is the leading indicator. That is the part of the warning that the El Niño now forming is going to make impossible to ignore by the time we get to the year-end summaries in January 2027. The reason that crossing matters is that it is the empirical confirmation of what the climate scientists have been saying since the 1980s. The Paris limit was set with a specific theory of when it would be approached. The theory said it would be approached gradually over the 2030s and 40s as accumulated greenhouse gas forcing continued to push the baseline upward. The reality is that we're about to cross it in 2026, 10 to 20 years ahead of the modal projection. The reason we are crossing it ahead of schedule is the combination of the rising background, the aerosol unmasking, and the El Niño signal landing on top of an already elevated state. The combination is exactly what Hansen has been arguing for, and what the more conservative institutional projections have been arguing against for the past several years. The June 1st plume is the data point that the conservative projections have to update against. The El Niño that is forming is the verification event for the Hansen position. We walked through the Hansen scientific reticence argument and the post-2020 aerosol unmasking literature in some detail in our video from the 18th of May on the atmosphere doing something nobody alive has ever seen. The relevant point today is that the El Niño contribution to 2026 is what converts the multi-year acceleration Hansen has been pointing at into a single-year threshold crossing. The crossing is the signal. The El Niño is the mechanism. And the crossing has a meaning that goes beyond the climate science community's technical framework. The Paris limit was not just a technical number. It was the political commitment that the international community made in 2015 to attempt to limit warming to a level that would keep the most catastrophic impacts off the table. The limit was set at plus 1.5 degrees because the science at the time indicated that warming above that level would push key tipping elements past their thresholds, would commit the planet to multi-meter sea level rise on timescales of centuries to millennia, and would produce climate impacts beyond what existing political and economic systems could absorb. The limit was political, but the limit was grounded in physical science. Crossing the limit, even in a single year, is the empirical evidence that the political commitment is not being met. The El Niño that is forming is the event that converts the political failure into something that the temperature records can confirm, and that is where the question of leaving the Holocene starts to become more than a metaphor. The Holocene is not just a name for the current geological epoch. The Holocene is the climate band that the entire time span of human civilization has existed inside. The temperature variance across the Holocene, reconstructed from ice cores and ocean sediments and tree rings and corals, has held within approximately plus or minus 1 degree Celsius across 11,700 years. That is the band. That is the window. That is the set of conditions inside which agriculture was invented, inside which cities were built, inside which writing was developed, inside which every empire in human history rose and fell, inside which industrial civilization emerged, inside which the modern world that we operate within today was constructed. We did not just develop inside that window. We built every system we have against the assumption that the window would continue. The 2024 annual mean global temperature is plus 1.3 degrees above the pre-industrial baseline. Hansen's 2026 prediction puts the year-end global mean at plus 1.5 to plus 1.7. The Holocene variance band is plus or minus 1. Plus 1.5 is, by definition, outside the band. Plus 1.7 is, by definition, well outside the band. The El Niño that's forming is the event that, if Hansen's prediction holds, makes 2026 the first calendar year of the entire time span of human civilization, in which the annual mean global temperature is measurably above the Holocene band. The leaving has been happening for 2 centuries. 2026 is the year the leaving becomes unambiguous in the annual numbers. That is the meaning of the central claim in this video. The El Niño now forming is going to be the seasonal scale event that pushes us through the door. The forecast just told us when we are walking through it. We're going to talk in detail in a few minutes about what the long baseline reconstruction shows and what it means for the variance band. Before we get there, we need to set up the visual that has been circulating online beside the SEAS-5 plume, because the 2 images taken together are the empirical statement of the entire argument. The plume is the proof of when. The reconstruction is the proof of what. We need to look at the reconstruction next. Part 6. The image that went viral beside the forecast. There is an image that started spreading across social media in May 2026, well before the June 1st 5 plume convergence dropped. It is not a forecast. It is a backward-looking reconstruction. It is the kind of image that climate scientists have been building for decades, but it is a particular version of that image that one of the leading climate scientists on his own X account picked up and recirculated in May with a single sentence of context. The sentence was that humanity, at breakneck speed, is leaving the stable Holocene climate in which human society developed and thrived, that weather extremes are outside historical experience, that sea level rise is accelerating, and that dangerous tipping points are ahead. The image, in other words, was being presented as the visual statement of the argument the El Niño forecast would shortly confirm. The image itself was built by a climate visualization team at the University of Reading, led by communicators who have spent years working out how to translate the structure of paleoclimate reconstructions into a form that a non-specialist viewer can read in 30 seconds. The image is titled in its caption, observed changes in climate over the last 2024 years. It plots 3 variables on a single chart, color-coded for visual separation. The top variable, in red, is atmospheric carbon dioxide concentration, measured in parts per million. The middle variable, in dark blue, is global temperature change relative to the pre-industrial baseline, measured in degrees Celsius. The bottom variable, in brown, is global sea level rise relative to the pre-industrial baseline, measured in centimeters. The horizontal axis runs from the year 1 of the Common Era on the left to the year 2024 on the right. The vertical scaling is chosen so that all 3 variables can be read simultaneously. And the most important visual feature of the image is a dashed vertical line, placed at approximately 1776 on the horizontal axis, labelled Invention of the Steam Engine. What the image shows is that for the entire 2,000-year window to the left of that dashed line, all 3 variables hold essentially flat. The carbon dioxide line stays between 275 and 285 parts per million for the entire time span. It looks, on the chart, like a horizontal line with minor variations. The temperature line stays within a narrow envelope of approximately plus or minus 0.3 degrees Celsius around the pre-industrial baseline. The medieval warm period registers as a faint positive bump in the 11th and 12th centuries. The Little Ice Age registers as a faint negative bump in the 17th century. Both are small enough that they do not break out of the visual envelope of the line. The sea level line is even flatter. It varies within plus or minus 2 to 3 centimeters across the entire 2,000-year window. To the eye, all 3 lines look like nearly horizontal traces with minor wobbles. To the right of the dashed line, all 3 variables bend. The bend is slow at first. Through the late 18th and 19th centuries, the carbon dioxide line creeps upward, the temperature line creeps upward, the sea level line creeps upward. Through the early 20th century, the bend accelerates. And after roughly 1980, all 3 lines turn into something visually different from anything that appears anywhere in the 2,000-year baseline to the left. The lines do not just rise, they hockey stick, they turn vertical. The carbon dioxide line reaches 424 parts per million at the 2024 endpoint, marked on the chart with a small label. That is 51% above the pre-industrial baseline. The temperature line reaches plus 1.3 degrees Celsius above the pre-industrial baseline, marked on the chart with a small label that is well outside the Holocene variance band that the line has held within for the entire prior 2,000 years. The sea level line reaches plus 26 centimeters above the pre-industrial baseline, marked on the chart with a small label. What makes the image work as a visual argument is that the 3 lines bend together. They share a single inflection point. They share the same dashed vertical line. The driver of the change, carbon dioxide, bends at the steam engine line. The response to the change, global temperature, bends at the steam engine line. The consequence of the change, global sea level, bends at the steam engine line. The visual statement is that the 3 variables are causally linked, that the causal link engaged at the moment human civilization began burning fossil fuels at industrial scale, and that the response has been continuous and increasing for 2.5 centuries, with the most extreme phase concentrated in the last 40 years. The image is, in effect, the entire empirical argument of anthropogenic climate change compressed into one chart. Anyone who looks at it and follows the timeline understands the structure of the claim. The data sources behind the image are worth knowing briefly. The carbon dioxide line is built from ice core measurements at 3 Antarctic sites, Vostok, Epica Dome C, and Law Dome, cross-referenced with the Mauna Loa Observatory continuous record that Charles Keeling started in the 1950s. The ice cores work because air bubbles get trapped in the ice as the snow compresses, and the bubbles preserve a literal sample of the atmosphere from the year the snow fell. The temperature line is built from the Mann-Bradley-Hughes 1998 Northern Hemisphere reconstruction, extended and refined by the Pages 2K International Consortium, and joined to the modern observational records from the United Kingdom Met Office, NASA Goddard, and NOAA. The sea level line is built from salt marsh sediment cores assembled by researchers like Andrew Kemp and Simon Engelhardt, combined with Robert Kopp's tide gauge reconstructions, and joined to the Topex, Poseidon and Jason satellite altimetry record that has been measuring sea surface height from space since 1993. Each of the 3 reconstructions has its own decades of peer-reviewed methodology behind it. The combination is the visual statement of the empirical case. What the combination of those three data sources on that single chart demonstrates is a single integrated empirical statement. The driver of climate forcing in industrial civilization is atmospheric carbon dioxide. The atmospheric carbon dioxide concentration was stable across the entire time span of pre-industrial civilization. It has risen by 51% since the invention of the steam engine. The response of the climate system to that driver is the global mean temperature. The global mean temperature was stable across the entire pre-industrial time span within a narrow Holocene variance band. It has risen by 1.3 degrees since the invention of the steam engine. The consequence of that response is the global mean sea level. The global mean sea level was stable across the entire pre-industrial time span within a band of plus or minus 2 or 3 centimeters. It has risen by 26 centimeters since the invention of the steam engine, with the rate of rise accelerating in the satellite era. The three variables plotted together demonstrate the causal chain: driver, response, consequence. They bend together at the same point. The chart is, as we said, the entire empirical argument of anthropogenic climate change compressed into one frame. The climate scientist who recirculated the image in May 2026 did not say anything that was not already in the image. He just put the sentence underneath that translates what the image is showing into plain language. He said, in effect, that we are leaving the stable Holocene at breakneck speed, that the weather extremes are now outside the historical experience that the previous parts of the image plot, that the sea level rise is accelerating, which the satellite-era portion of the brown line confirms, that dangerous tipping points are ahead, which is the implication of the trajectory the chart shows. The image, with the sentence, is the long baseline argument that the El Niño forecast is the short baseline confirmation of. The June 1st plume is one data point. The 2,000-year chart is the context that makes the data point legible. Together they are the empirical statement of where we are and what is coming, and the question that the chart and the forecast together raise is the question of what it actually means to leave the Holocene. We need to talk about that next, because the Holocene is not just a name. It is the set of conditions inside which everything we recognize as human civilization was built. Part 7. The stable Holocene, and what it means to leave it. The Holocene is a name from geology. It refers to the most recent geological epoch of Earth's history, which began approximately 11,700 years ago at the end of an abrupt cold reversal called the Younger Dryas, and which continues to the present day. The boundary between the Holocene and the preceding Pleistocene is defined by a specific transition in ice core records, a sharp warming that took place over roughly a century at the end of the Younger Dryas, marking the transition from glacial conditions to interglacial conditions. The Holocene is, in the long history of the planet, just one of many interglacials. The Pleistocene before it contained dozens of comparable interglacials separated by long glacial periods. The Holocene is not unusual in being warm. What is unusual about the Holocene is what it has been like to live inside it. The temperature variance across the Holocene has been remarkably stable. Multiple proxy reconstructions, integrating ice cores from Greenland and Antarctica, ocean sediment cores from every ocean basin, lake sediment cores from regions across multiple continents, tree ring records where they extend that far back, and pollen records from terrestrial sediments all converge on the same conclusion. The global mean temperature across the entire 11,700 years of the Holocene is held within approximately plus or minus 1 degree Celsius, around the early Holocene mean. The variance band is narrow, the wobbles are small. There has been no period of the Holocene during which the global mean temperature departed sharply from the long-term average. There have been regional excursions. The medieval warm period was warmer in Europe, the Little Ice Age was colder in Europe, but the global mean has held within the band. That stability is what made the Holocene unusual. It is what made the Holocene the climate epoch inside which something specific became possible. The development of agriculture, the Neolithic Revolution, the transition from hunter-gatherer societies to settled agricultural societies, the construction of the first permanent settlements, the emergence of writing, the development of metallurgy, the rise of the first cities and the first states, the construction of the great agrarian empires, the European Middle Ages, the Renaissance, the Scientific Revolution, the Industrial Revolution. Every social, political, economic and technological development that we recognize as the history of human civilization took place inside the temperature variance band of the Holocene. None of those developments could have occurred in a climate that was substantially warmer or substantially colder than the Holocene mean. We know this because every previous interglacial in the Pleistocene record had a comparable opportunity, and none of them produced civilization. The reason the Holocene is the epoch that produced civilization is, at least in part, that the Holocene was stable enough for long enough that the agricultural baseline could be calibrated against a predictable climate. That word predictable is important. The agricultural systems that human societies developed are calibrated against specific climate parameters: the expected timing and duration of growing seasons, the expected rainfall patterns, the expected temperature ranges, the expected frequency of extreme events, the expected location of major weather features like the Hadley cells, the jet streams and the monsoon belts. Every agricultural system in human history was developed and refined inside a climate that held those parameters approximately stable across the time span that the system was being developed. The crops we grow, the planting calendars we use, the irrigation systems we built, the storage methods we developed, the transportation networks we constructed for moving food from production regions to consumption regions. All of those systems were calibrated against the Holocene baseline. The systems work as long as the baseline holds. The systems begin to break down as the baseline shifts. The +1 degree Holocene variance band is the operating envelope of civilization. The +0.3 degree medieval warm period bump and the -0.3 degree Little Ice Age bump are the largest deviations from the mean that human civilization has had to absorb across recorded history. The Little Ice Age was associated with crop failures, famines, plague outbreaks, political instability, and the wholesale collapse of some agricultural systems in northern Europe. The shift was small in absolute temperature, perhaps half a degree below the mean for a period of 2 or 3 centuries, but the consequences were severe enough that they show up clearly in the historical record. The system was stressed by a fractional degree excursion that was well inside the Holocene band. The Holocene climatic optimum, sometimes called the mid-Holocene warm period, peaked approximately 6,000 to 8,000 years ago at perhaps plus 0.5 degrees above the long-term Holocene mean. That period was warm enough that the Sahara was vegetated and supported a wider range of human and animal life than it does today. The transition out of the climatic optimum back toward cooler conditions, around 5,000 to 4,000 years ago, was associated with the desertification of the Sahara, the collapse of some early Bronze Age civilizations, and substantial shifts in the distribution of human populations across the affected regions. The shift was, again, fractional, half a degree of cooling over a couple of millennia, and the consequences were substantial. The 2024 annual mean global temperature by every major observational record sits at plus 1.3 degrees above the 1850 through 1900 pre-industrial baseline. That value is outside the Holocene variance band. The band runs to approximately +1. +1.3 is past the band. We're already, in the present-day annual mean, operating outside the temperature envelope that human civilization has ever experienced before. The El Niño now forming is going to push the 2026 annual mean to a value that is further outside the band still. If Hansen's prediction holds, 2026 will land at +1.5 to +1.7 degrees above the pre-industrial baseline. That is 50 to 70% further outside the band than 2024. Every system we built was calibrated to operate inside the band. We are now testing what those systems do outside it. The planet has been warmer than the Holocene before. The Eemian interglacial, 125,000 years ago, peaked at perhaps +1 to +2 degrees above the pre-industrial baseline, and the mid-Pliocene 3 million years ago reached +2 to +3. But the Eemian had no Greenland ice sheet in its mature form, and sea level 6 to 9 meters higher than today. The Pliocene had a fundamentally different ocean circulation. Neither was a stable analogue for the modern world. The argument is not that the planet cannot survive temperatures outside the Holocene band. The planet has done so many times. The argument is that civilization in its current form was built inside the band, with every infrastructure system calibrated to the band, and that leaving the band fast in a single century in a single generation does not give civilization time to recalibrate. The Eemian transition happened over millennia into a world with no permanent settlements and no global supply chains and no coastal cities. The same temperatures, arriving into the modern world over the course of a couple of centuries, with the system architecture we have already built, are a stress test on systems with no resilience reserve to absorb them. The El Niño forming now is going to bring the global mean across a threshold the modern systems were not designed to operate above. That is what leaving the Holocene means in operational terms. When the climate scientists circulated the 2000-year reconstruction image in May, with the warning that humanity is leaving the stable Holocene at breakneck speed, he was not making a metaphorical claim. He was making a technical claim about the variance band of the proxy record, the rate at which the modern observational record is departing from that band, and the implications of the departure for the systems we have built. The technical claim is grounded in the data. The data shows a Holocene band of plus or minus 1 degree across 11,700 years. The data shows a modern annual mean at plus 1.3. The data shows a near-term trajectory that takes us further out. The departure is not theoretical. The departure has already happened in the present-day numbers and is accelerating. The El Niño forming now is the event that will make the acceleration impossible to dismiss in the 2026 and 2027 annual summaries. And the Holocene band is not just an arbitrary line. The band is the operational envelope of the systems we built. The +1 limit corresponds to roughly the bound of what the agricultural systems, the infrastructure networks, the political and economic structures, and the social arrangements of human civilization were designed against. The Paris Agreement aspirational limit of plus 1.5 degrees was set, in part, by reference to that envelope. The limit was the political acknowledgement that crossing the band by a sustained half degree would push climate impacts past the level that the existing systems could manage. The June 1st plume is the forecast that says we are about to cross that limit for the first time in any annual mean in 2026. The threshold the world committed to keeping below in 2015 is the threshold the El Niño now forming is going to break in the next 12 months. That is the meaning of the forecast. That is what it means to leave the Holocene. The phrase the climate scientist used in May was technically accurate. We are leaving. The forecast just told us the year of the formal crossing. The exit from the band is not happening because of one El Niño. The exit has been in progress for 2 centuries. The El Niño is the event that makes the exit unambiguous on the annual scale. The underlying trajectory was set by the Industrial Revolution. The underlying trajectory has been continuously increasing. The recent acceleration has been visible since approximately 1980. The threshold crossing is the leading indicator. The El Niño is the mechanism that produces the crossing. The climate scientists who have been warning about this for 40 years have been warning about exactly this configuration of events. The June 1st plume is the data point that converts the warning into a measurement. That is the long baseline argument. The El Niño forecast is the short baseline confirmation. Together they are the empirical statement. And the question that follows from the empirical statement is the question of what happens next. Because the climate system does not respond to threshold crossings in a clean linear way. The climate system has a set of components, identified in the scientific literature as tipping elements, each of which has its own threshold, and each of which, when crossed, reorganizes the system in ways that are not easily reversed. The El Niño that is forming will not just push the global mean past plus 1.5 for a single year, it will push specific tipping elements closer to their own individual thresholds. And the framework that describes those tipping elements and their interactions is the framework that turns the climate scientists' general warning into specific predictions about what to expect in the coming years. We need to talk about that framework next, because it is the part of the argument that explains why the question of whether the El Niño produces a response matters more than the question of whether the El Niño verifies. Part 8. The Tipping Element Framework. There is a paper from 2008 that is the foundational document of modern tipping element research. It was published in the Proceedings of the National Academy of Sciences in February of that year by Timothy Lenton, Hermann Held, Elmar Kriegler, Jim Hall, Wolfgang Lucht, Stefan Ramsdorf, and Hans-Joachim Schellenhuber. The paper is titled Tipping Elements in the Earth Climate System. The DOI is 10.1073/PNAS.07054141105. The authors were a team of climate scientists from major European institutions, working together on the question of which components of the Earth system could be pushed past their stable operating thresholds by ongoing anthropogenic forcing, and what the consequences of crossing those thresholds would be. The paper was the first systematic attempt to enumerate the tipping elements, to estimate the threshold temperatures at which each element would tip, to characterize the timescale of the resulting reorganization and to assess the potential for cascading interactions between elements. The paper identified a list of major tipping elements: the Atlantic meridional overturning circulation, the Greenland ice sheet, the West Antarctic ice sheet, the Amazon rainforest, the boreal forests of Eurasia and North America, the Indian summer monsoon, the Sahel and West African monsoon, the El Niño southern oscillation regime itself, which could shift to a more permanently El Niño-like base state at sufficient forcing, the Arctic sea ice cover, the Tibetan plateau snowpack. Each of those components, the paper argued, has a characteristic threshold of global mean temperature warming, above which the system reorganizes around a new stable state. Each threshold has substantial uncertainty in its estimated value, but each is plausibly within reach of the warming trajectory the planet is currently on. The most important insight of the Lenton paper was the framework of cascading tipping points. The argument was that the tipping elements do not exist as isolated components. They are coupled. Crossing one threshold may move another element closer to its own threshold. A weakening of the Atlantic meridional overturning circulation, for example, redistributes ocean heat in ways that affect the Amazon rainforest by altering the position and intensity of the South American monsoon. A dieback of the Amazon rainforest releases stored carbon into the atmosphere, which accelerates global warming, which pushes the West Antarctic ice sheet closer to its own threshold. A collapse of the West Antarctic ice sheet raises global sea levels, which destabilizes coastal ecosystems and political systems, which further reduces the capacity of human societies to manage subsequent transitions. The framework is one of interlocking thresholds. Crossing one is bad. Crossing the first one in a way that triggers a cascade across multiple others is qualitatively worse, because the cascading collapse takes the system to a new equilibrium that may be very far from the conditions inside which civilization developed. The 2008 paper was the founding document. The subsequent literature has refined, extended, and validated the framework. We covered the AMOC component in some detail in our video from the AMOC tipping points video earlier this spring. Let me recap the key results, because the AMOC is the tipping element that is most relevant to the question of what an extreme El Niño does to the cascade. The Atlantic meridional overturning circulation is the system of ocean currents that transports heat northward across the equator in the Atlantic basin. Warm tropical surface water flows northward as part of the Gulf Stream and the broader North Atlantic drift. The water cools as it moves north, increases in density, and eventually sinks in the Labrador Sea and the Nordic Seas. The sinking water flows southward at depth, completing the loop. The system carries enormous amounts of heat from the tropics to the northern high latitudes, and it is part of the reason that northern Europe is substantially warmer than other regions at the same latitude. The AMOC has been operating in its current configuration for approximately the last 11,000 years, the entire Holocene. Before that, during the glacial periods, the AMOC operated in different configurations or, during some intervals, was substantially weakened. The Caesar Ramstorff Robinson Föhlner-Saba paper from 2018 in Nature used the salinity and temperature signature in the subpolar North Atlantic to argue that the AMOC has weakened by approximately 15% since the mid-20th century. The argument is that as Greenland ice melt has added fresh water to the North Atlantic, the density of the surface water there has decreased, which has reduced the rate at which the surface water sinks, which has weakened the overturning circulation. The fingerprint is observable in the existing observational record. The Caesar paper put a number on it. The weakening is approximately 15%, with uncertainty bounds that include 0 to 30%, across the range of statistical models the team applied. The Caesar McCarthy, Thornalley, Cahill Ramstorff paper from 2021 in Nature Climate Change used multiple paleoclimate proxy reconstructions to argue that the current weakening is unprecedented in the last 1,000 years. The team looked at proxy records of AMOC strength from coral, sediment, and tree ring archives, and they found that the modern observational signal is outside the range of variability that the AMOC has displayed across the entire last millennium. The current weakening is not just a routine fluctuation. The current weakening is a signal that the system is moving toward a state it has not been in before in the Holocene. The Ditlevson and Ditlevson paper from 2023 in Nature Communications applied statistical analysis to the early warning signals of approaching tipping points, looking specifically at the AMOC. The team applied dynamical systems techniques, increasing variance, increasing autocorrelation, critical slowing down, to the long-term sea surface temperature record in the subpolar North Atlantic. The conclusion was a warning of a forthcoming collapse of the Atlantic meridional overturning circulation, with a central window between 2025 and 2095 and a median estimate at approximately 2057. The Ditlevson paper was controversial when it was published. The central estimate is at the early end of what most institutional projections put on the table. But the methodology is sound, and the underlying analysis has been confirmed and extended by the Bohr's 2024 paper in Nature Climate Change. The two papers together established that the AMOC is closer to its threshold than the IPCC-AR6 central projection suggested. The most recent contribution is the Portman paper from 2026 in Science Advances. The Portman team applied ridge regression to the observed pattern of sea surface temperature anomalies in the North Atlantic, comparing it against CMIP6 climate model simulations under different AMOC scenarios. Their conclusion is that the AMOC will weaken by approximately 50% by the end of this century, with a range from 42 to 58%. The key insight is that the CMIP6 climate models, the standard tools the IPCC uses for its projections, underestimate the observed weakening signal. The models are running too cold. The actual weakening is happening faster than the models predict. Stefan Rahmstorf, the Potsdam Institute scientist whose name appears on the Caesar papers and on the original Lenten tipping elements paper, has been making public statements about the AMOC for the past several years. His position, stated on his Substack and in interviews and at scientific meetings, is that the probability of an AMOC shutdown sometime in the middle of this century is greater than 50%. He has used the phrase most dramatic climate changes in 100,000 years to describe what an AMOC shutdown would mean. He has been arguing that the institutional climate science community has been too conservative in its public communication about the AMOC, that the data has moved past the conservative position, and that the public should be informed about the probability that an AMOC shutdown is approaching within the lifetime of people alive today. The Rahmstorf position is at the more aggressive end of the institutional spectrum. The Portman paper is closer to the conservative end, but both positions, taken together, describe an AMOC that is closer to its threshold than the standard projections of even 5 years ago put on the table. The reason the AMOC matters for the El Niño that is forming is that the El Niño is going to put stress on the Amazon. Super El Niños, at the magnitude we are forecasting, produce, historically, the strongest drought in observational record across the Amazon basin. The Amazon dieback element is, in the Lenten tipping elements framework, one of the major cascading partners of the AMOC. An Amazon under severe drought stress moves from being a net carbon sink, absorbing roughly 2 billion tons of carbon per year from the atmosphere, toward being a net carbon source, releasing carbon as biomass dies and decomposes. The shift accelerates atmospheric carbon dioxide growth. The accelerating carbon dioxide growth accelerates ocean warming, including in the North Atlantic. The accelerating North Atlantic warming, combined with the continued melt of Greenland ice, applies further stress to the AMOC. The cascade chain is loaded. The El Niño that is forming is the event that pulls the trigger on the Amazon component of the chain. We do not know whether the Amazon will tip in 2026 and 2027. The tipping element threshold is uncertain. The drought stress that the El Niño will apply is severe but is not necessarily past the threshold. What we do know is that the drought stress will be measurable, that the carbon flux response will be observable in atmospheric carbon dioxide measurements, and that the system will be pushed measurably closer to a threshold that the Lenten framework identified 17 years ago. The cascading tipping point framework is what makes the climate scientists' 4-decade warning specific. The warning is not general. The warning is not just that the climate is warming. The warning is that the climate system has specific components with specific thresholds, that crossing one threshold accelerates the approach to others, and that the cascade once initiated is difficult or impossible to stop. Each individual element has uncertainty. The cumulative probability that at least one major element tips in the next several decades is, under the conservative institutional projections, substantial. Under the more aggressive projections from Hansen and Rahmstorf and others, the cumulative probability is high. The El Niño forming now is not the event that produces the cascade by itself. The El Niño is the event that demonstrates the system is moving in the direction the cascade requires. It is the seasonal scale evidence that the longer-term trajectory is on the path the framework has been warning about for the better part of 2 decades. The question of what leaving the Holocene means becomes, under the tipping element framework, a specific question with a specific structure. The Holocene was the stable epoch. The tipping element framework identifies the components whose stability defines the Holocene. The forcing we have applied is approaching, or has approached, the thresholds at which those components transition out of their Holocene stable configurations. The El Niño that is forming is the event that confirms the forcing trajectory is on schedule for the threshold crossings. The framework gives us the specific predictions about what crosses first and what cascades next. The forecast gives us the timing on the immediate signal. Together they describe the structure of the trajectory the planet is now on, and they ground the warning in specific identifiable components rather than general concern. That specificity is what makes the warning hard to dismiss, and what makes the question of response the question that determines what happens next. We are not done with the technical setup, but we need to talk briefly about one more piece of the recent acceleration, because it is the piece that explains why 2026 was already on track to surpass 2024 before the El Niño signal even landed. The piece is the IMEO 2020 aerosol unmasking signal. It is a smaller contributor to the overall trajectory than the El Niño or the long-term greenhouse forcing, but it is the contributor that explains why the recent acceleration has run faster than the conservative institutional projections expected. We will cover it briefly. Part 9. The aerosol unmasking subplot. In 2020, the International Maritime Organization implemented a new set of fuel standards for the global commercial shipping fleet. The standards reduced the maximum permitted sulfur content of marine fuel from 3.5% to 0.5%. The change was implemented worldwide on the first day of January 2020, and it was driven by air quality concerns. Sulfur emissions from ship exhaust were causing measurable health impacts in coastal regions and major shipping lanes. The new standards were intended to reduce those health impacts by cutting sulfur emissions sharply. The standards worked. Shipping lane sulfate aerosol emissions dropped by approximately 80% following the implementation. What was not widely anticipated, at the time the standards were implemented, was that the reduction in shipping lane aerosol emissions would also remove a small but measurable cooling forcing on the global climate. The mechanism is straightforward, but worth explaining carefully. Sulfate aerosols, when emitted into the atmosphere, do 2 things. They scatter incoming sunlight directly, which produces a small cooling effect. They also act as cloud condensation nuclei. They provide surfaces around which water vapor can condense to form cloud droplets. When more sulfate aerosols are present, more cloud droplets form, but each droplet is smaller because the same amount of water vapor is being divided among more nucleation surfaces. Clouds with more, smaller droplets are visually brighter and reflect more incoming sunlight back to space than clouds with fewer, larger droplets. The aerosol-cloud interaction is called the Toomey effect, named after the atmospheric scientist Sean Toomey, who described it in 1977. The Toomey effect is one of the largest sources of uncertainty in modern climate models, because the precise magnitude of the cloud brightening is difficult to measure and difficult to parameterize. The aerosol-cloud interaction over shipping lanes was particularly important, because shipping lanes concentrate sulfate emissions into linear bands across the oceans, where the underlying ocean surface is dark and where cloud brightening produces a measurable change in the radiative balance. The bright tracks left by ship exhaust in marine cloud decks are sometimes visible from satellites, and they have been studied for decades as a natural experiment on the magnitude of the Toomey effect. When the IMO 2020 standards went into effect, the ship tracks largely disappeared. The cloud brightening over the shipping lanes was sharply reduced. The cooling forcing that had been operating along those lanes was removed. The question of how much warming the removal added to the climate trajectory is in active debate within the scientific community. The Hansen Group at Columbia and at the Climate Science Awareness and Solutions Program has been arguing in a series of papers and Substack posts beginning in 2023 that the unmasking added approximately plus 0.05 degrees Celsius to the recent warming acceleration. The Hansen 2023 paper in Oxford Open Climate Change made the case formally. The Hansen Substack posts in 2024, 2025, and 2026 have continued to push the argument. The argument is that the rapid acceleration in observed global temperatures in 2023 and 2024 which surprised many institutional climate scientists with its magnitude, was caused in substantial part by the aerosol unmasking signal landing on top of the existing greenhouse forcing. Several other research groups have produced supporting analyses. The UN paper from 2024 used satellite observations of cloud properties over shipping lanes to argue the cloud brightening reduction was consistent with a forcing change in the Hansen range. The Jordan paper from 2024 arrived at a similar range. The Met Office Hadley Centre and several other institutional research centres have produced more conservative estimates, generally placing the IMO 2020 contribution at approximately plus 0.01 to plus 0.03 degrees. The institutional position is that the unmasking is real but small, and that recent acceleration is mostly the trajectory the long-term forcing predicts. The disagreement between Hansen and the conservative institutions is part of the broader pattern Hansen has been calling out for years. The pattern is what Hansen calls scientific reticence. The argument is that institutional climate science has, across the decades, consistently erred on the conservative side in its public communication about the trajectory. The conservative bias is partly an artifact of how scientific communication works under uncertainty. When in doubt, understate. It is partly an artifact of the IPCC consensus process, which requires all member governments to sign off on each report, and which tends to produce projections that are politically palatable rather than scientifically aggressive. It is partly an artifact of professional incentives. Overstatement is punished more harshly than understatement in scientific careers. The result, Hansen has argued, is that the public communication of climate science has been systematically more conservative than the data warrants. The cost of the conservative bias is that the public has been informed that the trajectory is more manageable than it actually is, and that the response time available is longer than it actually is. The Hansen versus institutional restraint framing is a legitimate intra-scientific debate. It is not a conspiracy. The notion that climate scientists have been silenced is not correct. The notion that institutional communication has been more conservative than a respected minority within the field would prefer is the position Hansen has been articulating for 40 years. The June first sees 5 plume is one data point in the longer argument. The plume supports the Hansen position that the trajectory is moving faster than the conservative projections accounted for, that the El Niño contribution is going to push the global mean pass thresholds the conservative projections were placing later in the decade, and that 2026 will surpass 2024 by a margin that the conservative projections would not have predicted 6 months ago. Whether the Hansen position will be fully validated by the 2026 and 2027 observations is a question we will know the answer to in 18 months. The current trajectory is on the Hansen track. The reason the aerosol unmasking subplot matters for our central argument is that it explains why 2026 was already on track to surpass 2024, before the El Niño signal even arrived. The aerosol unmasking added approximately plus 0.05 degrees to the trajectory, by the Hansen estimate, over the course of approximately the last 5 years. The contribution is small, but it is part of why the recent acceleration has been faster than the conservative projections expected. When you combine the unmasking contribution with the continued underlying greenhouse forcing, and with the El Niño signal that is forming now, the cumulative effect produces an annual mean for 2026 that crosses thresholds. The conservative projections were not putting on the table for this calendar year. The aerosol piece is not the whole story. It is a contributor. The El Niño is the proximate event. The cumulative trajectory is what crosses plus 1.5, and that brings us back to the central argument of this video. The forecast is for an event at the magnitude of the worst climate-amplified humanitarian catastrophe in the modern era. The event is arriving on top of a baseline that is already outside the Holocene variance band. The contributions to the baseline include long-term greenhouse forcing, recent aerosol unmasking, and the El Niño signal itself. The tipping element framework identifies the components that are at or near their thresholds. The Lenton, Caesar, Ditlevsen, Burs and Portman literature has been narrowing the central estimates and pushing them earlier. The Rahmstorff and Hansen positions, which were at the aggressive end of the institutional spectrum a few years ago, are looking increasingly like the central case. The forecast is the data point that says the trajectory is on the path the most aggressive published projections expected. The trajectory was supposed to take decades to confirm. The forecast is confirming it in 2026. That is what is on the table, and the response to this trajectory, in the political and public discourse, has been muted. That is not because the data is absent. The data is loud. The published literature is extensive. The forecasts are explicit. The response is muted because the gap between what the data shows and what the public understands is large enough that the political centre of gravity has not moved in proportion to the trajectory. The gap is the variable that determines whether the warning produces a response. The gap is the structural feature of slow-onset crises that allows them to proceed without intervention. We need to talk about the gap because the awareness gap is, in the end, the determining variable of the entire story. The El Niño is the proof. The hockey stick is the context. The awareness gap is the question that is still open. Part 10. Less than 5%. Alongside the C's 5-plume and the 2000-year reconstruction image, a third observation has been circulating in the same online conversations. It is not a chart. It is not a scientific paper. It is a single line, posted by people who follow climate communication closely, repeated again and again in the same week. The line is some version of the same claim. Fewer than 5% of the population understands what is actually happening. The exact phrasing varies. The structure of the claim is the same. The number 5% is what gives the claim its weight, because the claim implies that there is a small, specific minority of the population for whom the data in the previous parts of this video is part of daily working knowledge, and a vast majority for whom that data is essentially invisible. The claim is supported by polling. The Yale program on climate change communication, based at the Yale School of the Environment, has been running a long-term survey research program called the 6 Americas Project for over a decade. The project segments the United States adult population into 6 audience categories based on their level of engagement with climate change as a topic. The categories run from alarmed, who view climate change as a serious immediate threat and are actively engaged with the issue, to concerned, who view it as a real problem but not personally urgent, through cautious, disengaged, doubtful, and finally dismissive, who reject the scientific consensus entirely. The percentage shares of each category have been tracked across multiple waves of the survey, from approximately 2010 to the present. The alarmed segment has grown over the past decade, but it is still only approximately 26% of United States adults in the most recent published wave. 26% is the upper bound on the share of the population that views climate change with the urgency the published science would warrant. But the alarmed category itself contains a range of engagement levels. Within the alarmed segment, only a subset is able to articulate the specific mechanisms of climate change with technical precision. They can name the major tipping elements, they can describe the ENSO cycle, they can locate the relevant tipping point thresholds within the IPCC framework, they can explain why the IMO 2020 unmasking matters. That subset, the part of the alarmed segment that is technically literate on the subject, is, by survey estimates, approximately 3 to 5% of the total United States adult population. That is the empirical basis for the viral claim. Fewer than 5% of the population understands what is happening in a technical, specific, actionable sense. The polling supports the claim. The polling has supported the claim across multiple waves for multiple years. The gap between what the data shows and what the public understands is the structural feature of the entire story. The published scientific literature on climate change is voluminous, accessible, and unambiguous. The major projections have been in place for 40 years. The forecasting tools have been refined for 30. The observational confirmation has been arriving consistently. The El Niño that is forming is the latest in a long series of empirical signals that the trajectory the climate scientists described is the trajectory the planet is actually on. The signals are not hidden. The signals are not technical secrets. The signals are published in journals available to anyone, summarized in press releases, repeated in news coverage, visualized in social media posts, explained in books written for general audiences. The information environment for climate change is not characterized by suppression. It is characterized by abundance. The signals are everywhere. The understanding of the signals is concentrated in a small fraction of the population. The disconnect is not a moral failure of the public. Calling it a failure would be unfair to the actual structure of the problem. The problem is that slow-onset crises against fast news attention spans are difficult for any population to absorb. The climate signal has been developing over decades. The news cycle works in days. The structural mismatch means that the climate signal never reaches the threshold of urgency that triggers full political mobilization, because each individual news event involving climate is too small relative to the underlying trajectory to drive mobilization on its own. The annual hottest year records have been arriving for years. The major hurricanes have been arriving. The extreme heat waves have been arriving. The Pacific marine heat events have been arriving. The Greenland melt events have been arriving. Each individual event is treated as one news story, absorbed into the cycle, and replaced by the next cycle's stories. The cumulative pattern, which is the actual signal, gets lost. The reason the awareness gap is the variable that determines the response is that the response requires sustained political will. The trajectory the data describes is not one that can be addressed by single policy interventions or single technology deployments. It requires the kind of coordinated, sustained, multi-decade response that political systems struggle to maintain even on much narrower questions. The condition for sustaining that kind of response is broad public understanding of what the data shows, broad enough to make the policy commitments durable through electoral cycles and institutional changes. The awareness gap is what prevents the broad understanding from forming. The structural feature of slow-onset crises is that they do not generate the urgency needed for the political response without crossing some threshold of public legibility. The El Niño that is forming is being put forward by the climate scientists who are paying attention as the candidate event that might cross the legibility threshold. The forecast is loud enough that the resulting 2026 annual mean will be unambiguous in a way that the previous incremental records have not been. Whether the unambiguous signal moves the awareness floor is the question the next 18 months will answer. What the central thread of this video has been building toward is the recognition that the awareness gap is the variable, the El Niño is the proof, the hockey stick is the context, the tipping element framework is the structure, the Holocene exit framing is the meaning. Each of those pieces of the argument has been developed in detail above. They sit on top of each other in a stack. The stack describes the situation completely. What determines what happens next is not any of the pieces of the stack. It is whether the population that needs to act on the stack can come to understand the stack well enough to act on it. The El Niño that is forming is the loudest seasonal scale signal the climate system is capable of producing. The +3 degree Niño 3.4 anomaly will produce drought across the Amazon, intense rainfall along the western coast of South America, severe heat across South Asia in 2027, weakened Atlantic hurricane activity offset by intensified Eastern Pacific activity, and elevated global mean temperatures during the event year and the year following. Each of those individual consequences will produce news coverage. Each will be absorbed into the news cycle. The cumulative effect, the underlying signal, will be the 2026 annual mean global temperature, which we expect to come in at +1.5 to +1.7 degrees above the pre-industrial baseline. That number, when it's published in January 2027, will be the single empirical statement of where the trajectory has landed. The question is whether that single empirical statement reaches the awareness floor in a way that the previous incremental records have not. The trajectory the climate scientists have been warning about for 40 years will, in 2026, produce a year-over-year signal that is unambiguous. The forecast says so. The question that remains is whether anyone is paying attention. Part 11. The counter-arguments and why they fail. Before we close out, we need to address briefly the counter-arguments that circulate in connection with the trajectory we have been describing. Honest treatment of the alternative positions is part of the channel's brief. We will go through them quickly, because the literature has addressed them and the answers are clear, but addressing them is part of closing the awareness gap rather than widening it. The first counterargument is that the SEAS 5-plume convergence is a product of model tuning rather than physical signal. The argument is that climate models are calibrated against historical data, that recent observed values strongly skew the calibration toward a warm bias, and that the model is therefore producing a forecast that reflects its own bias rather than the physics of the system. The argument fails to engage with the convergence of multiple independent modelling systems. The European Centre's SEAS5, NOAA's CFS version 2, NOAA's NMME ensemble, the United Kingdom Met Office's GLOW-C, the Japan Meteorological Agency's seasonal forecast, and the IRI multi-model assembly all produce Niño 3.4 trajectories in the same +2 to +3 degree range for late 2026. They do not share code. They do not share calibration. They were built by independent teams using independent methodologies. The argument that they all agree because they all have the same bias would have to explain how 6 independent modelling centres, working in 3 continents, all developed the same bias simultaneously. The argument fails on its face. The convergence is grounded in the observational reality that all 6 modelling systems are responding to. The second counter-argument is that the current warming is caused by a covert geoengineering program. The theory holds that some national or supranational actor has been quietly injecting sulfate aerosols into the stratosphere to manage planetary temperature, with the consequences being kept hidden from the public. The factual case against the theory rests on the Calypso satellite record, which has been measuring stratospheric aerosol concentrations continuously since 2006. The Calypso record shows the IMO 2020 signal, the decrease in shipping lane sulfate aerosols beginning in 2020, exactly as the IMO regulations would predict. A covert sulfate injection program would produce stratospheric aerosol loading data that increases over the relevant period. The observed data decreases. The covert injection theory does not match the satellite record. The theory also does not explain the long-term warming trajectory, which dates from the late 19th century and which was well documented before any plausible geoengineering capability existed. The IMO 2020 unmasking is part of the explanation for recent acceleration. The covert injection is not. The third counter-argument is that solar variability is the primary driver of current warming. The argument leans on the elevated activity of solar cycle 25, on the temporal coincidence of the current El Niño with that elevated solar activity, and on the secular increase in total solar irradiance across the early 20th century. The factual case against the argument rests on the magnitude of the solar forcing. Total solar irradiance has varied by approximately 0.1% across the satellite-era measurement record. That magnitude of forcing produces a global mean temperature signal of approximately 0.1 degrees Celsius, close to noise level. The observed warming since the late 19th century is approximately 1.3 degrees. The factor of 13 discrepancy is not explainable by solar variability. The IPCC-AR6 attribution assessment, the CMIP6 multimodal intercomparison, and every major independent attribution study place the anthropogenic contribution to observed warming since 1950 at greater than 95%. The solar contribution is real but small. It is not the explanation for the trajectory. The fourth counter-argument is that the climate scientists themselves have been silenced or marginalized by institutional pressure, and that the difference between what scientists privately believe and what they publicly state has grown to a dangerous gap. The factual situation is more nuanced than the strong version of the argument allows. There is a documented dynamic in which institutional climate science has historically erred on the side of conservative communication. James Hansen has been articulating that dynamic for 4 decades. He calls it scientific reticence. His position is that the institutional consensus communication has been systematically more conservative than the data warrants, and that the more aggressive published positions, including his own, have repeatedly turned out closer to the central case than the conservative projections did. The Hansen position is not a conspiracy claim. It is a critique of the institutional norms of his own field. The notion that scientists are being silenced is incorrect. The notion that institutional communication has been more conservative than a respected minority within the field would prefer is the position the more aggressive scientists have been articulating for decades. The June 1st plume is the kind of data point that supports the more aggressive position. The fifth counter-argument is that the term tipping point has lost meaning through overuse, and that the warnings have been repeated too often for them to be credible. The argument is rhetorical rather than factual, but it is worth engaging because it tracks a real frustration. The Lenton paper from 2008 specified threshold uncertainty ranges. The CESA 2018 paper narrowed the AMOC range. The CESA 2021 paper extended it further. The Ditlevsen 2023 paper narrowed it further still, placing the central estimate of amok collapse between 2025 and 2095 with a median around 2057. The Bohr's 2024 paper used additional fingerprint analysis to support that range. The Portman 2026 paper narrowed it further. The literature has been refining, not abandoning. The term tipping point has not lost meaning. The literature has been narrowing the meaning decade after decade. The current state of the literature places the central estimates of multiple major tipping element thresholds within reach of the warming trajectory we are currently on. The warnings are not generic. The warnings are specific. The fact that they have been repeated does not weaken them. The fact that they have been repeated and are now being empirically confirmed in real time strengthens them. Each of the counterarguments has a clean response in the published literature. None of them removes the trajectory the data describes. None of them changes the implication of the June 1st plume. Addressing them honestly is part of closing the awareness gap rather than leaving the field open for the counterarguments to fill the space. The science holds up against the alternative positions. The alternative positions do not displace the science. The trajectory is what it is, and the forecast confirms it. Part 12. The question that remains. The El Niño is forming. The data shows it. The June 1st sees 5 plume converged at +3 degrees by December. The observational only swing from -0.55 to +0.48 grounds, the forecast in the actual measured ocean. The subsurface Kelvin wave carrying +5 to +6 degrees at 100 meters is moving eastward as we speak, and 6 independent modeling centers are agreeing on the trajectory. The signal is not ambiguous. The signal is not subtle. The signal is the loudest seasonal scale signal the climate system is capable of producing on this timescale, and it is being produced right now. The climate is leaving the Holocene band. The 2,000-year reconstruction shows it. The carbon dioxide line has bent, the temperature line has bent, the sea level line has bent. The 3 lines bend together at the same point in human history, and the bending has accelerated to the point that the modern annual mean is already outside the band held inside for 11,700 years. The exit has been in progress for 2 centuries. The exit is happening faster than it was happening when our parents were born. The El Niño now forming is the seasonal scale event that will push the 2026 annual mean to a value that makes the exit unambiguous in the year-over-year numbers for the first time in the entire time span of recorded civilization. The warnings have been correct. The climate scientists have been issuing them with increasing specificity and increasing urgency for 40 years. The Lenten tipping elements framework from 2008 has been narrowed and validated across the subsequent literature. The CESA AMOC fingerprint papers from 2018 and 2021 have been confirmed and extended by Ditlevsen 2023 and Beers 2024 and Portman 2026. The Hansen scientific reticence argument from the 1980s has been repeatedly verified by data that has come in closer to the Hansen position than to the conservative institutional projections. The Kai 2014 paper on extreme El Niño frequency doubling under greenhouse warming is being verified by the event that is forming right now. Every major published projection that has been argued aggressively in the climate science community over the past several decades has been moving toward the central case of the data, not away from it. The forecast is the latest verification event. What remains, what is still genuinely open, is the question of what a population does when the slow onset crisis, whose physical signature is unambiguous, reaches a threshold of legibility. The El Niño that is forming is the candidate event for crossing that legibility threshold. The 2026 annual mean, when it is published in January 2027, will produce a year-over-year increase that is harder to absorb into the normal news cycle than the previous incremental records have been. The plus 1.5 degree threshold, the Paris aspirational limit, is going to be crossed for the first time in any annual mean. The crossing will be the leading indicator of the sustained crossing that the Paris framework was designed to keep below. The crossing will be the moment the political commitment of the international community to keeping the trajectory inside the Paris bounds is empirically demonstrated to have failed. The crossing will be a data point that climate communicators will reference for the rest of the decade. Whether that crossing produces a political response or is absorbed into the news cycle like the previous records is the variable that determines what happens after 2027. If it produces a response, the response will come in the form of accelerated decarbonization commitments, accelerated adaptation infrastructure, and accelerated political acknowledgement that the trajectory the planet is on is not the trajectory the existing systems were calibrated for. If it does not produce a response, the absorption will be one more piece of evidence that the structural mismatch between slow onset crises and fast news cycles is wider than even the most conservative climate communicators have argued. We do not know which outcome is going to occur. The forecast tells us when the test event is. The test event is 2026 and 2027. The response is what we're going to watch unfold in real time. The climate scientists who have been issuing the warnings have done their part. The literature is voluminous and clear. The forecasting systems are mature and converging. The observational network is providing real-time confirmation. The technical work has been done. The remaining variable is not technical. The remaining variable is whether the broader public, the broader political class, and the broader institutional systems that decide what gets prioritized and what does not are capable of absorbing the signal at the magnitude the El Niño is about to produce it. The viral observation that fewer than 5% of the population understands what is happening is, in the end, the empirical statement of the bottleneck. The data is there. The understanding is concentrated in the small fraction. The signal at the magnitude the El Niño will produce is loud enough that it may, finally, push past the bottleneck. Or it may not. We will know in 18 months. The Holocene was the climate epoch that built civilization. The temperature variance band that defined the Holocene was the operating envelope of every system we built. The Paris Commitment from 2015 was the political acknowledgement that crossing the variance band by a sustained half degree would push the climate impacts past what the existing systems could absorb. The June 1st plume is the forecast that says we're about to cross the variance band by half a degree at least in a single calendar year. The crossing is 1 year. The trajectory is the longer pattern. The trajectory has been confirmed over and over by every new observational dataset that has come in. The El Niño is the next confirmation. The crossing is the next milestone. The cascade described in the tipping element framework is the structure of what happens after the crossing. The climate scientists have done their work. The forecast tells us when the next event is. The trajectory tells us where the next event leads. The Holocene window is closing. The signal is being produced at the loudest level the system can produce it at. The question, the only question that is still open, is whether the rest of us are paying attention. The June 1st plume is the answer to the question the climate science community has been asking for 4 decades. The awareness gap is the question that determines whether the answer is acted on. The El Niño is the proof, the hockey stick is the context. The awareness gap is what is left. Civilization developed inside a window, the window is closing, the forecast just confirmed it. The question is whether the warning produces a response, or whether it is absorbed like every warning before it, and the next one, until the window has closed completely. The climate scientists have done their job. Whether the rest of us do ours is the only variable still open.